Today we're beginning Chapter 8. Before really beginning the content in Chapter 8, let's do some reminders about square roots. An expression has square roots in it like square root of 75, 2 divided by square root of 18, 18 divided by 5 root 6, or 8 divided by 6 root 2. Those things are simplified if, 1, each square root you see is simplified. In other words, nothing inside any square root can be divisible by a perfect square. This idea we've already looked at. 2, there are no square roots in denominators of fraction. This is called rationalizing denominators. We're not going to worry about that phrase at the moment, but that's the idea behind no square roots in denominators of fractions. Number 3, all fractions are reduced or simplified. So let's simplify the following square root expression. Square root of 75 can be thought of as, is there a perfect square that lives in 75? Yep, it's 25. So step by step, if we write it out, we can have 25 times 3, which is the square root of 25, times the square root of 3. So the answer is 5 root 3. Because the square root of 25 is 5. The second one, there is a square root in the denominator, and that cannot be. So what we want to do is we want to take out the square root in the denominator. So what can we multiply this by? Some factor of 1, so the square root of 18 goes away. We could multiply it by the square root of 18 divided by the square root of 18, which is just 1, isn't it? So that numerator times numerator, you get 2 root 18 divided by, what's root 18 times root 18? That is just simply 18. What two numbers multiplied together gives you 18, same numbers. Okay, let's see, can we do a little bit more work? Well, 2 goes into 18 once, so we're gonna, now we can take a 2 out of here and get 1, 2 out of here, we get 9. So now we have square root of 18 divided by 9. But the square root of 18 has a perfect square in it. The perfect square is 9. So the square root of 18 can be written as square root of 9 times the square root of 2, because 9 times 2 is 18. Square root of 9 is 3. And again, we can simplify a little bit more. So our final answer is 2 root 3. Moving along, the next problem. Let's see, for this one, I can see we have a, no, I'm up here. For this one, well, we have to get rid of the square root of 6 somehow. So again, we can multiply this by something to remove the square root from the denominator. So we'll have 18 root 6 on the numerator. 5 times root 6 times root 6. Well, root 6 times root 6 is simply 6. 6 times 5 is 30. Okay, so now we have to think about, all right, what is there something to take out of 18 and 30? Well, I think there's a 6 that lives in here, so 6 goes into 18 3 times. 6 goes into 35 times. So the final answer would be 3 root 6 over 5. 3 root 6 over 5. I leave this practice problem for you to solve. You pause the video and do this problem, and when you are finished, I will meet you on the next page. Now we're ready to start about right triangles. In particular, today we will focus on what happens if you take a big right triangle and cut it into 2 right triangles by drawing the altitude to the hypotenuse. So how many triangles do I see now? I see a left one here, a right one here, and I see the big one, triangle ABC. So let's redraw and see if we can see a relationship between the 3 triangles. Here is the big triangle here, ABC. If I think about the big triangle to the left triangle, well, the left triangle has a right angle, an angle A, and the big right triangle has a right angle, an angle A. So we can set up a similar relationship between the left triangle and the entire triangle ABC. I'm going to line it up here by putting A here. The right angle mark is going to go up here, and basically I'm lining these up to the original. Angle A goes here. Angle D goes up here because that's the right angle on the left side, and the leftover vertice has to be C. So angle A matches up with angle A. Angle C, which is a right angle, matches up with angle D, which is a right angle in the left triangle. And now we're going to do the same for the right triangle. Okay, now I can see in the right triangle, angle B lines up with angle B in the big triangle. So let's go ahead and put the big angle B refers to angle B. The right angle in the right side triangle is going to be also angle D. And the leftover is C. So ABC would be similar to ACD, would be, and so would ABC be similar to CBD. The altitude creates three similar triangles. So let's go ahead and say triangle ABC is similar to, right up here, ABC is similar to ACD. And if you're not sure, you just line up the angles. Triangle ABC is similar to triangle CBD. If those things are both similar to ABC, that means they must be similar to each other because all the angles are going to line up. So triangle ACD is also similar to triangle CBD. So when faced with a picture like this one, it can be hard to know where to start. So many triangles actually make it tougher since there are 9 different proportions to write down. Trying to redraw 3 triangles each time can be tedious. So we'll focus on some of these all-purpose proportions. And honestly, we don't have to memorize the all-purpose proportions. I'm going to give us a sheet that we can always refer to, so you don't have to memorize them. But let's see if we can figure this out. The first one. Okay, here's the altitude, which is the altitude from the original triangle, a piece of hypotenuse and a piece of hypotenuse. Find x. Let's just redraw this first one. So if I look at this left triangle here, we have 3 and x. That's this left triangle here. Now let's think of this triangle over here. If we spin it around and line it up, it's going to look like this. 8 and x. And these are similar triangles. So we can set up the proportion that 3 is to x as x is to 8. If you want a little more work with this, just refer back to your geometry book and it gives you more examples of how to do this. We get x squared equals 24. X equals the square root of 24. And that can be simplified to be square root of 4 times the square root of 6. So the answer in simplified form is 2 root 6. In general, when faced with a diagram like this, you can automatically state the following, that A is to X as X is to B. And how I think about it in words is by saying a piece of the hypotenuse is to the altitude as the altitude is to the other piece of the hypotenuse. Let's look at this again. So, in this example, 3 is to x as x is to 8. A is to x as x is to b. Turning the page, The following situation is also true. If we think about a leg of the big right triangle and a piece of the hypotenuse and the other piece, we can also set up another kind of relationship. And it turns out when you spin the triangles around, as an example 2, if you put 4 here and y here and the right angles here, and notice this is sort of like our angle A in the last page, we can line that with angle A in the big triangle, but now we're going to put this is going to be 13. I have this mixed up here. And the right angle's here. No, I'm okay. But now notice that the right angles are not in the same place. This is why. So I'd have to spin this upside down to look more like this. Put the right angle down here. The angle here. So the distance from here to here is y. And the distance from here to here is 13. So these two are similar right here. And they're lined up correctly. So y is to 4 as 13 is to y. Cross multiplying, we get y squared equals 52. Y equals the square root of 52. And what's inside 52? Well, there's a 4 and there's a 13. So the answer is 2 root 13. When faced with a general picture that looks like this, you can say that A over Y equals Y over A plus B. Or in words, we would say the piece of the hypotenuse is to the close leg as the close leg is to the entire hypotenuse. And of course, we're talking about the hypotenuse of the big triangle. So a piece of the hypotenuse, which is A, is to the close leg, which is Y, as the close leg, which is Y, is to the entire hypotenuse, A plus B. Again, we don't necessarily have to memorize these, we just have to be able to use them. So let's do example 4, set them up together, and you can solve them out yourself. So if I give it a picture like this, for me the easiest one to always do is this one. 3 is to H as H is to 7. So that would be one setup. A piece of the hypotenuse is to the altitude, as the altitude is to the other piece of the hypotenuse. And the other one we just learned is that piece of the hypotenuse, 3, is to the close leg, which is A, as the close leg, which is A, is to 10. So that's the second one. And the third one, we would have here, this is another leg, isn't it? Isn't B another leg? We would have the piece of the hypotenuse, which is 7, is to B as B is to 10. So doing those out mathematically, you will get 3 answers for A, B, and H, and we can check them in class tomorrow. So you need to finish example 3, finish example 4, and finish example 5 tonight, and we'll talk about all these things tomorrow.